This is for Year 12 methods. It comes out of Chapter 14, 14A, question number 19. A manager of a shop knows from experience that 60% of her customers will use a credit card. Okay, so we've got credit card and P equals 0.6, not credit card, and that's going to be a probability of 0.4. Find the probability that. Okay, so in A, I know exactly what happens. We have 3 customers that use credit card and then 3 customers that don't. That's not binomial because I know that on the first customer it was a credit card, not 2 options. And I know on the second one it was a credit card, not 2 options. And on the third it was a credit card, and the fourth didn't, and the fifth didn't, and the sixth didn't. On each event, there was only one outcome, and I know that it happens. That's 0.6 by 0.6 by 0.6 by 0.4 by 0.4 by 0.4. So 0.6 to the power of 3, 0.4 to the power of 3, and that's going to equal 0.28. Okay. From B onwards, it is binomial. 3 of the next 6 customers will use a credit card. Now that's become binomial because there are 6 customers and the probability of using a credit card is 0.6. But when the first customer walks in the store, you don't know if they're going to use a credit card or not. And you don't know which of the 6 customers are going to be the credit card users and which ones are going to be not the credit card users. Whereas this one over here was just a string and I knew what the string was. So part B is probability that x equals 3, and that will be binomial PDF, where x equals 3, n equals 6, and p equals 0.6. And that probability I'll get by going interactive, distribution, discrete, binomial PDF. I'll do that again, interactive, distribution, discrete, binomial PDF, where x equals 3, that equals 6, that equals 0.6, and I get an answer of 2765, 0.2765. Part C, at least 3 of the next 6 customers will use a credit card. So probability that at least 3. Now that's going to be the probability that x equals 3, plus a probability that x equals 4, plus a probability that x equals 5, plus a probability that x equals 6. Now I don't want to do 4 calculations, so I'm going to use binomial CDF, which will give me a range, and I'll go from 3 to 6. And what that looks like is interactive, distribution discrete, CDF, where my lower is 3, my upper is 6, because I went from 3 all the way up to 6. Number of trials is 6, and the probability of success is 0.6, and when I press OK, that gives me 82.08, so equals 0.8208. And then part D, I can see a big fat given word there, which means I have conditional. Exactly 3 of the next 6 customers will use a credit card. So probability that x equals 3 given that at least 3 of the next 6 customers use a credit card. So it's a probability that x equals 3 given that x is 3 or more. And that will be the probability that x equals 3 intersect x is bigger than or equal to 3 over the probability that x is bigger than or equal to 3. And I know that my denominator is 0.8208 because that's what that is, 0.8208. this intersection, if I look at my number line of 0, 1, 2, 3, 4, 5, and 6, this is 3, this is 3, 4, 5, and 6. This is the intersection, so it's the probability that x equals 3 over the probability that x is bigger than or equal to 3, and that was the probability of equaling 3, 2, 7, 6, 5. So it's the last two answers, so I'll take that answer and I'll divide it by that answer. It's not always the last two answers. It happened to be the last two answers in this case. So 3368, so 0.3368. So just to recap, while it looked like they were all binomial, the first one is what I call a string, because I know what happens. The last three were binomials. So if I was to do a tree diagram for the first part A, I would have the first customer comes in, I know they use a credit card. Second customer comes in, I know they use a credit card. The third comes in, I know they use a credit card, then they don't, then they don't, then they don't. It's not a tree diagram because I know the outcomes. Whereas B and C, I don't know of the 6 which three or more used credit cards, and that's why I'm going to use the binomial to do that.